We have seen in our previous session how difficult it is to solve any bigger problem using a traditional software design approach. That's where the machine learning comes to our aid, and to know what machine learning is, let's get into it. Machine learning is a subset of artificial intelligence that enables computers to learn from the data. Yeah, here the computer is given with the data and say that, look, this is data, understand the data, understand the features hidden inside the data, and get ready to answer my questions. So that is how we create some sort of intelligence to the machine, and that is through what we call making machine learn from the data, that is machine learning. So the machine learning will improve the performance without being explicitly programmed. So we don't have to understand the complete domain, we don't have to understand how to solve the problem, and then we don't have to explicitly write a program to solve that problem. So what we require is the data. So when we were talking in the last session, the major problem with any computer engineer is that he or she will be working in some unknown domain, having no expertise about that domain. Then what are we actually trying to do was trying to imitate the domain expertise through our software. So we meet a expert who is the domain expert, and then interrogate with the domain expert and try to understand how the expert solves a problem, and we try to simulate that through our code. Today that seems impossible because the expert is far beyond the understanding of any software engineer. So what we can do is try to understand what the expert is doing instead of understanding how expert solves the problem. So today the advantage we have is, one, lot of data is available. Two, the processing capacity has increased. So taking these two into considerations, so what we can do, instead of interacting with an expert about how the expert solves the problem, just look at the past history of the expert and fetch the data available with the expert, the previous problems expert has already solved, collect all those data, and then ask our machine to see that these were the problems given to the expert, and that was the solution given by the expert. So can you connect the two ends, the problem given to the expert and the solution given by the expert? Can we connect any link between these two? Not as a human me, but I want my machine to connect the links. So while connecting the links, it will learn how the things are interrelated and all that, and that is what we call machine learning. So we don't have to understand how the problem was actually solved by the domain expert, but instead we can collect the past solutions of the expert, whatever problems the expert has already solved, collect all those data and then dump onto our machine and ask machine to learn the connection between the question and answer. And once we make our machine understand the relation between question and answer, then our machine will be ready to answer any new questions related to that particular domain. That is the basic concept of machine learning. And through this we can create machine more intelligent. So here the machine learning will be provided with data and algorithms that allow the system to recognize the patterns, and once the patterns are understood from the data, then this pattern can be used to make future decisions or predictions. So that is the main concept behind the machine learning. Question comes is, why do we require that? The first thing is the traditional programming works well for simple rule-based problems only, but the real-time problems any domain faces cannot be put in simple set of rules, and hence the traditional way of solving cannot be used for it. So whether it's speech recognition or medical diagnosis or fraud detection, so it is almost impossible to create the rules manually, and since we cannot create rules manually, then the traditional programming cannot be used for that. So for example, if I ask you how to write A, yeah, so it is almost everybody knows how to write A, but what we can do, we can write A, we can recognize A if it is written, but the problem is I cannot explain someone else verbally how to write A. I can show how to write A by writing A, but I cannot verbally say how to write A. And believe me, A is the simplest thing anyone learns in the life. And A itself, that's the simplest thing we are unable to express in words. Then imagine explaining the domain expertise in words. It's almost not totally impossible. So that's a major problem we do have, is we can't just make rules for any expertise. For that expertise, what is expert means? So first thing is that expert has got a studied something and developed some knowledge, and using that knowledge has done some activities, and through the activities he has gained the knowledge, the expertise, and that expertise will simply make the expert to solve a problem. But when it comes to explaining how it is solved, not possible to explain, because solving a problem by an expert involves many things. One, the past studies, then the knowledge gathered in all the past years, and the problem solving skills acquired during the current working duration. So this experience and all that, everything collectively, something happens inside our brain which we call knowledge, and that's what we call an intelligence. And that intelligence is one that helps us immediately come out with the answer without explicitly working on it like a program does it. No, we don't work like a computer working on a program. We are wired in a different way, our brains are wired in a different way. So if we are talking about understanding A, B, C, D and all that, what is actually happening is the A written by our teacher on the board is seen by our eyes, and she keeps telling that this is A, this is A, this is A, and whatever she is saying that this is A, this is A, it goes into our ears. So what goes into our eyes ring a bell in some part of the brain, and what goes into our ears ring another bell in another location in our brain, and these two firing occur every time A is being taught to us. We see A, we hear A, we see A, we hear A. These two things are happening all the time simultaneously. So two parts of the brain are getting fired simultaneously when we are trying to learn A, and because of this, connection between these 2 points is created, and this connection creation is what we call learning. How it actually happens, no one can answer it. That's only an approximation that some neurons get excited when you see A, and some neurons get excited when you hear A, and these two neurons, a connection is created between them, and that is what we call learning. Same thing happens whenever we are experiencing any new thing, whenever we are learning. So when we talk about a domain expert, then so many such things have happened with that person. So many places neurons are getting fired, and so many new connections are being done, and through all this, an intelligence is created, and through that intelligence he is able to solve the problem, and that is not possible for that expert to tell verbally how the problem is solved and all that. But yes, of course, in the backend we have various cases that expert has already solved. So take those cases as a reference and try to find a pattern in that, and that is what we call machine learning, and that's why we want to work with the machine learning. So machine learning is one which allows systems to adapt and improve automatically by learning from experience. Yes. So imagine that you are working with some 10 questions from a particular topic. So you have studied some topic, and now you are familiar with 10 questions and their answers. Now what happens when you get into an examination hall? You get a question, you know that it belongs to that particular topic, but the question in the question paper doesn't exactly match with all these 10 questions. Yes, but still we try to correlate this question with the 10 questions we have, and then on the same way we try to correlate those answers and somehow extract the required answers from those 10 answers and put it on one answer. This is what we call intelligence. So we do use our intelligence, deeply go into our knowledge bank and look for what we are interested in, and if it is directly available, just dump it out. But if it is not available, then look all around and try to find anything nearby is available. If so, then try to extract what you want from that and put it out. So that is intelligence. So we are trying to make a machine intelligent. That is what we call artificial intelligence, and here it is going to allow the systems to adapt to new situations, improve automatically by learning from experience. They do some, when you ask a question, it gives some answer, and from the feedback it understands how good the answer was, and depending on that feedback, the same answer to be repeated again for similar question or not to be repeated again is decided, and then the next time a similar question is asked, this answer to be used for creating new answer or not is to be decided, and this whole process is what we call learning. So that's the difference between the traditional and machine learning, if you look at it. So if you look at our approach, then the traditional development, here programmer explicitly defines the rules and logic. Here we have to understand everything in detail and put everything on paper and then decide it. But whereas here we don't do anything, we just dump the data and we ask system to learn the rules or patterns from the data. We just give the data and we ask you find the rules and the patterns from that. The input to the traditional software system is rules plus data we give, and we get an output. So we have rules, so with that rules we write a program, and to that program we feed the data and we get the output. Whereas in the machine learning case, we have collected the data from the expert and we know what for that data or what that data means. So we have data as well as the output, both of them we feed to the machine and let machine create the rules. So it will give us the learned rules. So about handling capacity, so this traditional one works well for simple problems like creating payroll, billing, etc., but cannot handle complex tasks, uncertain tasks and all that. So but machine learning can comfortably handle any complex situation, uncertain situation, unstructured problems like image processing, language processing and all can be comfortably handled by machine learning. Adaptability, so a lot of manual updates are required if something changes, but here automatically it gets adapted. The moment you change the data, the whole system, the whatever system you are talking about, will now start working for new set of data. So if it was working for identifying animals and now you start giving input to the machine to identify the birds, then the same process it will start identifying the birds and all that. So adaptivity is very simple because the basic rules are fixed, that is take the input, take the output, take the data, take the output, create a model. So whatever is input output, the logic is the same. And scalability, when the problem becomes more complex, then scalability is a very big problem, whereas it's going to improve with more data and more computational power. So you have more data, you are more happy because more the data we have, more better our machine can learn it. So it is like writing A 10 times. Instead of writing A 10 times, you write A 100 times, then you will be more perfect in that. So the more exercise you do, the better learned you will be. The same way, the more data we have, definitely our performance is going to improve. So it's scalable, easily scalable. So the size of the data and all that will not matter much when it comes to machine learning. So that's the difference between the traditional and machine learning. So as of now, that's it for now. Thank you.